Okay, everybody. Hello, everybody. Thanks for joining us today for removable Benarx Epoxy boxes on the actuators and the valves, the next generation fireproofing. And this is the technical webinar. My name is Damien. I will be the moderator for today's presentation, together with my colleague Adrian Christian Holland. So before we start the presentation, I would like to go over a few details about the webinar logistics. So first of all, the webinar is fully recorded. So after the webinar, we will upload this on the YouTube platform and send you the link. So if you have colleagues who are interested in this webinar, but by some reason they couldn't participate today, you can send them the link and they can watch this webinar anytime they like. Number two, after the presentation, which will take approximately 55-60 minutes, that's at least our goal, we will run the Q&A session. So we look forward to receiving as many questions as possible. That's why we have this webinar. We want to get the questions from you, and we will try to respond on them due to the limited amount of the time. If by some reasons we are not able to reply on all questions, we will gather all questions and we will reply on them after the webinar, and we will send you the list with the questions and with the answer. The last thing is after the webinar, for those people who are participating in today's webinar online, we will issue the certificate of the completions. So we will contact you individually and we will send you the certificate afterwards. Please try to a little bit you need to wait for the certificate, because we have to wait quite a lot of certificates due to that we have quite many participants. Okay, so some questions, some information about the presenters. So maybe I will just start with my introduction. So my name is Damien Kumurkiewicz. I'm technical sales manager, global technical sales manager for Benarx Epoxy Products. I'm working here in Benarx for nearly 6 years. I mean, 10 years in the oil and gas business right now. And I've studied oil and gas engineering at the University of Science and Technology in Krakow in Poland. Here you have my contact details. So if you have any questions related to the webinar or to the presentation or to the Benarx fireproofing system, feel free to contact me after the webinar.
Hello everyone, I'm Adrian Holland. I'm engineering and R&D manager for the Benarx Epoxy product series in Benarx. I have a background as master in engineering in material science, and I've been working now in Benarx for approximately 9 years. If you have any technical questions or technical related inquiries, you will also find my contact details here, so please feel free to stay in touch.
All right. Okay, so I think we should start somewhere with a basis, explaining to the audience and to the people and to the industry why removable fireproofing should be used for the valve actuator, which is the topic for this webinar today. So of course, the actuators is the critical safety device which must shut in the valve underneath. So it must be fireproof, and due to the maintenance inspections reasons, it must be removable. With a valve, it's a similar story. It's a critical equipment which control the flow path on the pipeline, and due to that, we are talking about the oil and gas industry, like a refinery, LNG, like petrochemical facilities offshore. They all process the hazardous hydrocarbons, flammable fluids. And also, from time to time, the project must have access to the valve, so the fireproofing should be removable. So, yeah, that's the short story. In the next slide, you can see the different fires that there are so many industrial evidence since oil and gas was established in our world. that if you just Google it, you have a lot of evidence that the fire happened on this tank terminal, it was blasted in this refinery, that you have some catastrophic fire incidents on the offshore platforms like Deepwater Horizon in the Gulf of Mexico or Piper Alpha in the UK offshore sector. So this is really a big threat for us, for our industry. And the one of the intention of our company is, of course, to protect the critical infrastructure and the human up against the fire. When it comes to the fire event and fire incidents, this is the typical aftermath that you can see after the fire. Of course, no one will allow to go there inside except the regulators and inspection team. But you can find a lot of photos as an aftermath after the fire. So that caused, as you see, catastrophic results when it comes to the critical infrastructure. And of course, to the sometimes in the worst case scenario, human losses and injuries. And of course, environment, there is a big impact also for the environment due to the oil spillage, etc., etc. So the same story, it's also for the offshore industry when they are typically located in the offsite locations. Here you have a short case study from one fire incident in UK, which was happened in 2005. You can find a lot of info in the internet about it. But the fire was happened in 2005, and it was oil terminal, and that over 20 oil storage tanks were affected by the fire. And according to the information we are able to find on the internet, it was over 40 injuries and unconfirmed 8 human losses. And after the fire, one of the UK government agency, they calculate the approximately cost due to this incident. And you can see that dramatic cost. It's above 1,150 million euro. And this also a governmental agency in UK, they calculated the preventions measure for what would be the total cost of these measures or the solutions to protect the critical infrastructure. And according to this calculation, it would cost approximately 32 million euro, which represent a little bit around the 2.5% of the losses related to this one incident. We would like to also explain you how the projects are following when they deal with the fire protection. We are in the passive fire protection since 2002, and we noted the 2 ways how they do it. You have API 2218 standards. I'm pretty sure you are familiar with this and you have heard about it earlier. And in this guideline, it says that there are some certain equipment, like vessels, like a valve, actuators, steel structure, and piping, and the nozzles and critical pumps. They must be fireproofed according to some certain criteria. And in respect to the valve actuators, this guideline often states this is the full fire limits according to UL 1709 fire cure. But the second way is also that specialized department, either in the EPC or in the end user side, typically this is built by a technical process safety department. They are doing the risk assessment studies. So in fact, they are simulating the fire on the certain installation unit. And according to the results of that, they select, okay, this valve and this actuators, it's inside of the fire zone. So so removable fireproofing must be utilized, while others, they're outside of the fireproofing, so not needed for the fire protection of those actuators.
Yeah, so just to give some basic introduction on the different type of fire scenarios that we often encounter. We can start with the most basic type of fire, which is not so much used in the oil and gas industry, but many are familiar with from the building and industry sector, which is the cellulosic fire. So this is the one that you see in terms of temperature in the blue line here on the graph on the upper right. So in a cellulosic fire, you have some sort of flammable building material, being wood or all of flammable substances, and you start off typically around 500-600 degrees, and the fire gradually increases in temperature throughout the course of the fire duration. What's different in oil and gas processing facilities is that there are flammable liquid, there are flammable gases. When these substances are released at large scales and ignite, the temperature rises much more quickly. So in terms of temperature, it's quite common to simulate pool fire or large-scale fire incidents in the oil and gas industry with a hydrocarbon fire curve. This is the curve that's seen on the red, the green curve here, and it rapidly goes from ambient up to approximately 1100 degrees, much more rapidly than a more traditional cellulosic fire curve. We have pressurized vessels with gas and flammable gas and liquids in oil and gas processing plants, so we also encounter jet fire. Now, the line in pink here is a little bit misleading because in reality jet fire is much more violent, it's much more fluctuating. So a jet fire can be anything from 1100 degrees up to 1300 degrees, in some cases even higher. It depends on the chaotic nature of the pressurized release. But generally, we are significantly higher in temperature and also in other aspects such as erosion and additional impact to the system. Yeah. So two of the most common test standards or standards that we use to simulate these type of environments is the hydrocarbon pool fire. The most widely adopted one being UL 1709, and in case of jet fire, ISO 22899. The UL 709 goes quickly up to approximately 1100 degrees or 1093 degrees Celsius, which is it's because it's 2000 degrees Fahrenheit, so it's an American standard. That's why it's not exactly a round number. The heat flux in a real hydrocarbon pool fire can be anything typically from 100 to 250 kilowatts per square meter. But in the UL 709 hydrocarbon temperature environment, it's more close to 250 kilowatts per square meter. It's on the high end of the scale. In terms of jet fire, as I said, it fluctuates widely throughout the test, but typically we will see the temperature somewhere between 1150 and 1300 degrees. But it's a very, very violent pressurized release, so it's not like this even, nice, standardized graph that we showed on the previous graph. Typical heat fluxes for a jet fire environment can be anything from 250 kilowatts per square meter up to 350 in the case of the more severe high heat flux variant of the jet fire test standard. So that's a little bit introduction to the testing. When we do the testing, we also bring along third-party witnessing. The reason why we do this is that we later on seek to apply for type approvals. So a type approval is an assessment or a document issued from a third-party body, for example, Lloyd's, DNV, Bureau Veritas, or others, that certifies the performance, the test pieces, the results, the thicknesses undertaken in the test. Another aspect which I haven't mentioned earlier is the steel massivity. We've tried to illustrate this on the upper left figure here. As we all know, thicker and heavier pieces of steel take longer time to heat up and cool down. And this is the same or equivalent in a fire scenario as well. If you have a high steel thickness, a high mass steel section, it will perform better because it takes more heat energy to heat the steel up. Conversely, if you have a very light or thin-bodied steel body, it will heat up much quicker. So this is also a key aspect that goes into the certification in addition to the results themselves. And in the end, when you have the type approval, you can also apply on a project-specific basis for DID, or Design Assessment Documentation, or DVR, as some other third parties company call it. Yeah, next one. So what's the difference between a type approval and a DID or DVR? The type approval is a general document. So the type approval lists the performance, the witnessed test results, the type of test object, the steel specimen itself, the performance, the thicknesses, the duration in the fire, what critical temperatures you meet for such and such duration, etc. Together with the test standard and the steel massivity as well. But it's a general document. It doesn't certify or appraise any specific project-specific case or any specific, typically valve model or actuator model. It's a document that lists all the tests you have done, its performance, and maybe also some thickness tables or performance tables that you can use to pick out epoxy thicknesses and such. Design appraisal documents, DIDs or DVRs, as some call it, that's a project-specific appraisal. So a DID gives the project case-by-case or project-by-project assessment and appraisal that the design proposed meets the specification for that specific delivery of fireproofing. The DID cannot be reused in the next project or applied to other equipment or other scopes of work, and it's quite costly since you have to issue it every time. A typical cost for a DID can be something like 4,000 to 8,000 euros for each assessment. So it's something that's perhaps more cost-effective or relevant for larger scopes or larger, more critical deliveries. It's not typically something that we see on small 1, 2, 5, 10 actuator deliveries. It's something that's more relevant to consider for more high priority projects. Yep.
All right, so let's talk a little bit about the design criteria for the removable fireproofing and in general PFP. So in order to calculate the fireproofing thickness, we have to get some input data from the project. So this is normally the type of the fire. Is it a pool fire or is it jet fire, or is it a combined version together pool and a jet fire? Then the fire duration, like a pool fire 30 minutes or jet fire 1 hour. And one of the most critical components, it's a failure temperature for the valve and actuator. We are not dealing with the same stuff like with a structural steel, which typically refers to the either 400 Celsius degree or 538 Celsius degree. But with valve and actuators, the failure temperature it's a far lower. But we will talk about the details about that a little bit later. Operating temperature for the valve, it could be, for example, 60 Celsius degree or 100 Celsius degree. Surrounding air temperature, like a project ambient temperature, it's important because we have to calculate the temperature rise and of course the object massivity. What's the weight of the valve or what's the weight of the actuator? Due to that, it's so many different types of the valve and actuators. Some of the components they weigh like 10 kilograms, while they could easily weigh approximately 2 or 3 tons in the heaviest options. And it's also the special requirements like a green water slamming loads. When you have, for example, the FPSO and due to the harsh offshore conditions, some riser ESDB might be placed below the hull level and they are exposed for this wave impact and wind impact. So, for example, the project can call for the 1 barge green water slamming load, and 1 barge here represents 10 tons of the force per square meter. And another case could be the same, the blast overpressure also refers to the barges, and the cryogenic cold spill release that refers mainly to the LNG liquefaction facilities when they have a very complex cryogenic process under the high pressure. And due to the compact design, yeah, the CSP might be present due to that during the cryogenic presence of the medium, the steel can be brittle. So the object sometimes require both the combination of the PFP and the CSP, and sometimes just the cryogenic cold steel protection demand in that particular case. Coming back to the failure temperature, this is like a king of the story because, as I told you earlier, it's not the same like with a structural steel. Since we are work a lot with the valve and actuator makers, and we are working with the end user and EPC, and historically we supply a lot of Benarx fireproofing for the valve and actuators. The failure temperature is far lower. There are two ways of the project how they want to handle it. They either have a default ratings in the project PFP specifications. For example, for the actuator, it's a 100 Celsius degree, while for the valve, it could be, for example, 120. But sometimes also the project follows the data from manufacturer datasheet, so it could be also find there. So on this table, you see the different components of the both for the valve and for the actuators. So you have electric actuators, you have a hydraulic actuator, you have a pneumatic actuators, and then the same story is without the valve, different types of the valves. You have also the control panel connected to the actuator. You have a gearbox, which is the transmission drive to the electric actuators. And you have some other components like a mounting bracket that's to be allow the valve and actuator to be installed on site, and the volume tank which supply the air, for example, to pneumatic actuators. And in the failure temperature table in the section, we also wanted to notify the project what's our experience with the failure temperature. But we recommend to follow either the project specification or try to follow the manufacturer data sheets. Also, this is important information for the vendor because, for example, the project states that they want to have, for example, this valve to be fireproofed with a removable fire protection products, and they stay pool fire 30 minutes according to UL with a failure temperature 150 Celsius degree. The vendor must send for revision to the project team to confirm with a type approval test result that according to their test report, the temperature inside of the fireproofing product will not exceed this 150 Celsius degree. If exceed, the product is not qualified, it cannot be used. If it's below, then it's qualified. So this is important information to notify. And also, it's important to take into account the ambient temperature and also operating temperature to calculate the temperature rise in this particular case. Okay, so how our now we are going to talk a little bit about the Benarx fireproofing. So our product is a modular. It's fully removable and reusable. It's made from a stainless steel skeleton, like a reinforcement. Which we'll show you on the next slide, and it's covered with epoxy intumescent coating, both inside and the outside. And for removability, we use the different fixing methods. We can use the locks, we can use the banding, we can use the hybrid, we call it, which is the combination of the locks and the banding. For some particular cases, we can also design the inspection hatch in our box, just to, for example, on the control panel, to have a rapid access to the control panel, avoiding the taking entire box off from the actuators, for example. Then we have air gap solutions, which is the distance between the box and the object. For example, air gap is 30 millimeter as an example, and that gives you the space to accommodate the tubing and cabling inside. It gives you the ventilation functions, and in case of any water ingress, the water will be not stuck here, so always come down to the bottom side of the boat. Yeah, we are equipped also with the identification pledge. We can be equipped with a sniffer tube, which is there for the leak detection. That's particularly important for the flanges. We can design the watershed. This is the roof principle, just to avoid the water ingress inside of the box. We utilize the fire rating drain plug. This is for a drainage function, so water will be drained out from the system constantly. But in case of the fire, the hole with a drain plug will be sealed off in case of the fire, so it's fire integrity intact. The sealant we use just to seal the joints, and this is a particular use for the weather protections, nothing related to the fire performance. We use the expandable seal. This is to fulfill the small gap between our box and the object if we came across this special cases. Here we have an example how the box is made. So of course we try to follow the object shape, and we first of all we do the design, and then we start the manufacturing, and we make the stainless steel skeleton in a sheet metal workshop. And then after, if this is completed, then we go to the epoxy department when we start application of the epoxy tumescent coating, and we apply this both inside and outside. Then we apply the logs and the primer and the top coat as a corrosion protection system. And before the shipping, we also do the pre-assembly work if all parts fit together. It's also important to let you know how our box works in case of the fire. So this is our thermal insulation barrier. It's epoxy tumescent coatings. So for this particular case, we use the epoxy tumescent coating. We use the Shartec technology from AkzoNobel. And in case of the fire, the epoxy tumescent coating, it's expanding. It starts swelling. It could expand up to 8 times the original thickness. So if you have, for example, 10 millimeter thickness box, then after the fire, it could be reached up to 80 millimeters. So due to this expansion, it covers its swelling and protect the object up against the fire, and also covering the additional components around. Here we have an example of the different Benarx epoxy boxes for the different applications. Here you have the example for electric actuator with a gearbox inside, and also hand wheel outside, which is in a compliance with the API 2218. Then we have a boxes on the horizontal and vertical position. Then you have boxes on the hydraulic actuator with an inspection hatch to the control panel, and the example of the boxes for manual operating valve. Going to the details, since we also noticed there is more and more demand for the fireproofing for the electric actuators, we want to just show you how it works when it comes to the electric actuators. So we can protect the electric actuator as well. The box consists of several parts, depending how a box is big, what's the thickness, and we typically follow the split when it comes to the weight, 25 kg per part. So this is in compliance with all HSE regulation, most of the country. Then we have openings for the tubing and cables accordingly. When you have the hand wheel and the lever, we can easily accommodate to be designed outside of the box due to the emergency reasons. And since this is electric actuator, so you have this bank terminal, you have an electronic display, you have a on-off button. So we can, for example, design the easily removable parts, or we can design the inspection hatch. There are a few ways how we can do it, but we managed to do it, and that's our approach here. Valve and actuator, they also have critical components like air filter regulator, like a solenoid valve and the control panel. And in our experience, most of these components must be fireproof as well, especially solenoid valve and the control panel. So here you have a case when the box was inside for the hydraulic actuators with a control panel and air filter regulators inside, and we designed it easy to remove the inspection hatch, so mark up in the red. Then you have electric actuators with a gearbox, as I showed you on the previous slide. This is how we accommodate the typical cubic cable penetration. So we typically drill the holes on the box joints. When it comes to the API 2218, it says that the limit switch box or valve positioner or visual indicator that should be outside of the fireproofing to check what the status of the valve, if it is in the closed or open position. So here you have this particular case, and the last pictures it's about the Benarx Epoxy Box for the actuator with the mounting brackets. Sometimes we also came across the request the mounting bracket should be outside, it should be inside of the fireproofing, despite it's just the metal component, there is no fluid inside, but it works as a supporting functions to the actuator. So just to avoid the blending in case of the fire, the projects want to fireproof the mounting bracket as well. We have a lot of different types of the mounting brackets. This one is small revision of the API 22 guideline. Of course, we are not talking about the entire guideline. We just extracted the most relevant information for this particular webinar. And what API 22 says when it comes to the removable PFP. So first of all, it says that the valve and actuators, and for some particular cases, stated in the standard, the control panel and critical instrumental or signal lines should be fireproof as well. So here you have the case with the actuator, with the valve, with the cable trace consisting the cables and the control panel. Then, of course, due to the emergency reasons, the hand wheel and the clutch lever should be outside of the fireproofing for the maintenance. So they want to close the valve in case of the fire manually. Then you have the limit switch box. It should be placed outside to check the valve status. Is it open or closed position? When it comes to the ventilation, to avoid the overheating of the actuators, for example, or in general to avoid the heat retention, the ventilation function should be provided. For this particular case, we use the fire-rated drain plugs. Of course, the vendor must provide the fireproofing thickness calculation report. So we all the time supply this to the project as a part of the standard documentation package. And when it comes to the motor or gearbox, it should be inside of the firing, since this is critical component for the electric actuators, for example. So we can also do that. This is overview of the installation. So this is one project from Iraq in Halfaya, when the project stated the full fire 30 minutes according to UL 1709, and we have to fireproof the actuators, mainly rag and pinion actuators and hydraulic and pneumatic actuators. And the project ambient temperature was a plus 40 Celsius degree, and the failure temperature for the actuators was 100 Celsius degree. And according to this data, we calculate the thickness 20 millimeters. The box weight is approximately 100 kilograms, and it consists 12 parts. And we did the trial installation in the workshop, and it took us 50 minutes to put box together, all parts together. We have no problem to state that Benarx Epoxy Box is a maintenance free system. But to be more practical, we want to let you know what could be actually the typical activities when the box is in place and it's up and running and it's performing as intended. So sometimes, of course, the sealant can be broken. So what you need to do, you have to just remove the sealant and reapply the new one. Sometimes the lock can be damaged, so it's easy to just to remove the ticket. Just to remove the locks and apply the new lock. And if, for example, if you scratch also the box surface, our standard color is white, and this is just the top coat. So this is not like epoxy into mesh and coating. If you scratch the box, simple local repair, like touch-ups, will fix the issue. So this is the typical activities that sometimes can happen on site. Adrian?
Sorry, I was muted. So this is to share a little bit what standards we typically test against and which standards we most commonly encounter in the projects. For the hydrocarbon part, as I mentioned earlier, UL 1709. We also see a lot of IMO type hydrocarbon curve, and according to the British standard BS 476 per 22. And for the Russian market, we have the GOST and TR standards. For the Jetfire, it's typically specified according to ISO 22899, but there is also a higher heat flux variant called high heat flux Jetfire. This is not according to any international standard yet. There is a new standard coming out for that, I believe quite soon, but I'm not sure what the date is. A novelty here is the new Firestream hose test standard, NFPA 290. Now this is actually a combined test with Jetfire and water hose impact. I will talk a little bit about that in some of the next slides to show what it is. We have traditional cellulosic fire curves. We don't see those quite so often in the oil and gas industry. Explosion testing is often specified specifically on gas-dominated assets. And there is often a requirement for weatherproofing or aging tests or weathering tests. We have accommodated the ISO 23340. This is actually an older test standard. The new revision is 12944, if I remember correctly. And then we also follow the ISO 288 for cryogenic jet release and immersion scenarios. In some cases, we run into acoustic performance. So we have tested our epoxy series against acoustic performance, particularly on circular geometries in terms of boxes and pipe shells. And all our products are tested for anti-static discharge. So this is the intent to make sure the products don't electrically charge up during operation due to contact or friction with other substances and cause sparks that can lead to ignition on flammable or hazardous zones. Yeah, next one. So to give you an impression how, for example, a Jetfire looks. So on the left side here, you see a particular case of a test piece that was tested many years ago. This is a panel type arrangement. So it incorporates a flat steel panel on the back side, and there is a H-beam actually fitted in the middle here. So this is for structural applications. And during the Jetfire, propane gas is released at 0.3 kilos per second. So you can imagine 20 or 30 liter tank of propane that you would have at home being spent every single minute. So the amount of heat generated here is enormous, and the noise level as well due to the hypersonic release in the jet. In the Jetfires, there's also quite a bit of erosion. So all this turbulence and gas flow actually blows away a significant part of the expanding intumescent material. So that's another reason why it's in some cases tougher than hydrocarbon fire, is that you have this erosion factor in addition. Yeah, next one, David. Here's an example how a cryogenic test looks like. In this test setup, a liquid nitrogen gas is impinged at the test object. So for a test for 60 minutes like this, a full tanker of liquid nitrogen is used. I think in this test we used 9 or 10 tons of liquid nitrogen. So it's an enormous amount of liquid, extremely cold gas that's blasted onto the product, cooling it down to extreme temperatures. Straight after the cold phase, the test object is moved into the Jetfire chamber, and within 10 minutes, it's immediately exposed to Jetfire scenarios where the temperature typically goes in excess of 11, 12, 100 degrees, maybe even higher. So the thermal shock here is enormous. And that's also a part of the purpose of the test. No, it's fine. I talked a little bit about the more extreme or severe variant of the Jetfire that's going above some standards, so to speak, which is the high heat flux Jetfire. In this test, which is shown on the left side here, a larger jet fire chamber is utilized in order to increase the flame size and the radiation of heat onto the test object. This causes the temperature to go much higher and for the test object to experience much higher levels of heat radiation. And it's actually so extreme that in many cases the liners of the furnace itself have to be replaced regularly because they start melting. So it might seem similar to a regular jet fire, but it's quite extreme actually in comparison. An example of an explosion test on the right side here, or a snapshot taken during the explosion test. In this type of test, an explosive mixture of gas is mixed inside a test container, and the test objects are placed typically at the end of the object. With explosion testing as well, there is no or very little standards to follow. So the practice used by each laboratory may actually change a little bit here. That's also part of what makes explosion testing so difficult in terms of type approvals and third parties. Yeah, next one. Here you see some snapshots from a recent fire stream hose test that was undertaken. In this test, a combination of an initial jet fire exposure followed by high pressure water impingement, followed by a subsequent second phase of jet fire testing is conducted, and the purpose is actually to test the product's function when it's exposed to erosion from water jet impact like this in the middle of the test. So it's a little bit of a curiosity or a novelty, at least for our system, to have done this test. Coming back to explosion, one thing is the testing, but as we know, every object is different, every geometry is changing for every project. So in order to address the effect of geometry, thickness, different blast loads and directions on the object, we regularly also undertake final element analysis of the different box geometries for valves and actuators. And this is just to double verify the performance demonstrated in the test, to show that the geometry doesn't negatively impact the resistance to blast to such an extent that the integrity will fail.
All right. When it comes to the design engineering for Benarx fireproofing system, we can utilize several sources of the fires or input data. That could be the 3D models by working with a valve and actuator manufacturers. They have very accurate 3D model. If the 3D model is not available, we can follow the GE drawings or 2D drawings. We can also follow the 3D scans, but about the 3D scanning, 3D scans, we will talk a little bit later. And of course, if either the 3D models or 2D drawings are not available, and the refinery, for example, they have some valve and actuator to be fireproof, and the drawings and the models get lost, then we can follow the manual side measurements. So we can design based on that. That our design team will be able to design the removable Benarx epoxy box based on that. 3D scanning technology right now is with us for many years, so it is not novel technology anymore. And we started working with a 3D scanning technology over 8 years ago, and we've built the high competence with this tech because we supplied over 3,000 boxes already for the multiple spectrum of application based on the 3D scans. So we can rent this scanner to the project. It's a simple iPad device with a scanner on the top with a simple app. So the user has to launch the app. They have an orange cube. They can zoom in, zoom out, rotate the cube. And during the scanning, they need to make sure that the valve or actuator or any object is inside of this cube, and going around, scan the object from every single corner and send the 3D scans to our email. And then we can carry on our design. So here you have a case study from Article G2 where the actuators were installed on the module, and it was fully erected and equipped. And then our business partner managed to do this 3D scanning, and this is enough information to us. As you see, it's enough for us to design the box. Then we supplied the design drawings to the project. We manufactured the boxes, and then the box fitted as intended on the actuator. During the, we are right now living most probably in the post-COVID world, but 3 years ago the situation was different quite a lot, because it wasn't allowed to have a face-to-face meeting. It was a problem to bring own service team to the project, and that caused a lot of disruptions in the supply chain and material availability, and that impacted us as well. So, but before the COVID, we secured a few projects as well, and one of the potential solutions we implemented was the remote services. That helped us a lot because we developed the remote training for the external installers. So first of all, we can be sure that our box is installed according to our type approval certificate and according to our installation manual, and we can maintain the warranty for the box after the installation is in place. So it's a 1.5 hour video for the remote installation. It's held by one of the best supervisor, and he will guide the company or the project how to install our box, how to do the simple modification, what's the best practice for the installation. The same story is with the remote supervision. Due to the COVID, wasn't possible to supply the supervisor, the field supervisor, to the project. So we were operating based on the team's supervision or based on the photo documentation, and we were validated the installation based on the photo documentation and sometimes based on the team's calls. Yes, when it comes to the documentation, just short information. We typically supply the standard package to the project when we got the order from the project. So this is the typically it's material safety data sheet. This is the product data sheets. It's type approval, certificate of origin, the weight report, and the installation manual, and the fabrication drawings. But if the project have any special requirements related to, for example, to ATP or blast simulation or mechanical simulation or custom build installation manual and all other type of the documentation, we can of course supply to the project if requested. We would like to show you also how the box looks like after 10 years. We got the photo. That was Ormen Lange gas processing plant in Norway in the time that was for Shell. And we supplied there nearly 1,000 boxes for different applications. The boxes were installed in 2007, and we inspected them in 2018. So I'm not telling you the box look like a new from the factory, but taking into account the weather conditions. There are 4 weather zones there. The box has been most probably reinstalled, removed and reinstalled by external installers. And you have a different temperature from a -10 up to +15 Celsius degree over the year. I think the boxes looks quite okay after 10 years in service. This is another example. At the right side of the slide, you have a box on the valve. After 10 years, it was installed in 2006 and inspected in 2016. And recently, also we've got the sample of the box which was in service for 16 years from the same plant. This LNG liquefaction facility. For one of our leading customer, Equinor, and what we intend to do is we would like to run the new fire test. What's the fire performance of the Benarx fireproofing with the product sample after 16 years in service? This is like an ultimate assurance about the Benarx fireproofing performance after some time duration. So we are look forward to conduct this test around Q4 this year, maybe Q1 next year. This is also an example this time from offshore. The boxes for the project in UK and in Australia for offshore platforms of LNG. The boxes after 7, 8, and 5 years respectively. This is the slide about our track records, an example of our track records for the downstream markets. So right now we supplied our boxes, Benarx boxes, to every single continent. We are approved by the most of oil majors. We recently also got the ADNOC approved, so we look forward to working with ADNOC in the near future as well. It's all type of the petrochemical, chemical refinery facilities, oil storage, gas compression plant, gas treatment plant, etc., etc. This is the small case study from LNG liquefaction Snøhvit. This is the offsite location close to the North Arctic Circle. We supplied 2,000 boxes for a different application, mainly valves, flanges, manholes, nozzles, a little bit for pipes as well. So you see the boxes with the ice on the box surface. There was the big pressure in respect to the schedule for the delivery. We serve our client in the best manner. So we advise them where to terminate the fireproofing. Shall we include the flanges? What's about the inspection hatches? Shall we put our gearbox inside or outside? And also it was in that time, due to that the boxes were supplied and installed in 2006, or I think it was between 2006 and 2007. It was the drawings weren't accurate enough in that time. So we also had to do the simple measurements in that time and design the boxes based on the measurements from the site. This is the case from Arctic LNG2, one of the first box we supplied there. We carry on based on the free discounts. The partner supplied us also some photo documentation about the surroundings. He took some photos for us, and we've got the free discounts, and we designed the box on the valve, and it fitted as intended. Another case, this time for actuator with a mounting bracket. So this time the project we also fireproof not just the actuator but also with the mounting brackets. For this particular project, it wasn't a different demand. It was the demand for a jet fire. It was demand for a pool fire. It was also demand for the cryogenic jet release and the combination of the fire and the cryogenic cold spill release. So it was quite demand, and the failure temperature was also quite low. I think for the actuator was 100 Celsius, while for the valve I think it was 150 Celsius. Yeah, this is the IRAC project, Hellfire gas compression station and low pressure and high pressure compression station. We supplied approximately 200 boxes for hydraulic, pin and rack, and hydraulic actuators. It was a project driven by the pool fire spec according to UL 1709. Previously, the project used different solutions. They have a problem with the cabling inside of the previous fireproofing product. It was too little air gap. And they faced some problem with the armored cables, which consist the hard insulation outside. And due to this air gap, they struggle to fit them inside. So they have a special demand when it comes to the air gap, and they have quite also low temperature, low failure temperature for the actuator. It was, I think, 100 Celsius degrees. This is also the track records list for offshore. Typically, offshore projects, they follow jet fire standards. That's at least our experience sometimes, but also we experience the pool fire spec as well. But I think 70% of the spec is a jet fire related. We work with also with most of the oil majors like Total, Equinor, Petrobras, Eni, SBM, Shell, Exxon, and others. This is one of my favorite case study. This is from Ivar Aasen offshore platform. We supplied there over 5,000 boxes for the majority was for the actuators and for the valves, but also for the piping, for the nozzle, pipe supports, and others applications. So you see the case where it's a very little space around, so very space limited area. And it was also a quite tough fire spec. This time the project want to place control panel outside of the fireproofing, and we have to accommodate all these cable trays, all other instrumentation components around our boxes. So everything has to be in line and functional as previously designed. And the limit switch box, of course, should be outside of the fireproof. One of the last track record, this is this time for the floating vessels. So we work right now with all kind of the floating vessels projects like FPSO, FLNG, FSRU, FPSO, and all the similar projects. This is of course for offshore. Yeah, we typically supply the Benarx fireproofing, for example, for risers ESDV, including the riser and fitting and riser hang off. And for some of the projects, they also have a quite high demand when it comes to the blast over pressure and green water slamming loads. So we have to, for some particular cases, we had to perform the extensive engineering simulation, as Adam previously mentioned. This is the track record. This is the case from FPSO Egina for Total in Nigeria. We supplied their 325 boxes for valve bodies, for HPPS system. This is high integrity pressure protection system, typically used when you have this overpressure surge in the pipeline. And we supplied our boxes for that. And the right photo on this presentation, this is the riser ESDV, which is placed a few meters above the water level. So it's also a box for the wave impact, wind impact, etc. As we promised in the invitation in the webinar, we would like to give you a few information about the trends when it comes to removable passive fire protection solutions. So of course, first of all, is cost optimization. That's why we perform this full-scale testing with a valve and actuator inside to bring the cost down and to come up with the lowest thickness possible and to be in line with our type approvals and the fire specification. We also integrated our boxes with an intelligent sensor, but I will show you. I will talk a little bit about that later on. Yeah, we conduct the full-scale testing with the valve and actuators. We will do the full scale. We will do the fire test with a box after 16, 17 years in the service. It's also important to avoid the heat, the heat retention and overheating in the valve and actuator, because it can reduce the lifetime for the valve and actuator itself. It's important that the fireproofing product is truly removable and reusable, and it's and assure us about this long service life, minimum 20 years. So this is the typical the warranty from EPC when they build the new projects. We would like to prevent the cables and the tubing twisting and buckling. So that's why the RGAP will help us a lot. We conduct also the remote operation, like a remote training, remote supervision, which I talk a little bit earlier. And if required, we also doing the finity element methods for the complex jobs, for the complex scope of the work. So traditionally, for the tubing cable penetration, we just drill the holes in the box joints and fulfill with epoxy into mesh and tape. So everything is in the fire integrity is intact. But we also get some requests from the project if we can come up with some cable glands. And we've managed to integrate the cable glands, which is the components to attach and secure the electrical cables. So these cables which coming to limit switch box or air filter regulator, yeah, we can integrate the cable glands with a plate and integrate it to the box surface. And these cable glands, they have a certain ingress protection. There's typically IP66 or IP67. It can be used, it can be utilized both for the indoor and outdoor applications. And we have different variation depending on the thread size, typically from M20 to M20 up to M25, and with a different thread length and different inlet and outlet size. So this is how it looks like in reality. As I told you at the beginning, accommodation of the tubing and cabling inside of the fireproofing, it's important. We have enough space there for the cabling. So we have this air gap solution, and it helps the projects to put those cables inside there.
Yeah, so to give some sneak peek into the recent tests that we've been doing for the box system. Last year, we undertook a set of very small actuator tests. These tests were performed on the very light body aluminum and plastic electrical actuators. So we wanted to see not only how it performed with this low weight, this low massivity in the fire scenario, but we also wanted to challenge with this low massivity, with this low weight, how would the penetration of the operating wheel through the box impact the thermal performance in the test. So we tested a total of 6 different specimens for hydrocarbon fire, rapid temperature rise, and we were very excited to see, anxious to see how the operating wheel would affect the thermal performance on such small actuators. And to our surprise, the performance not only performed well relative to the low mass of the object, but we actually didn't see that much effect of the operating wheel penetrating through the box. It was a little bit surprising. We had expected more heat coming in from the operating wheel like this, but we're quite comfortable that we've done some testing, some proof of performance to actually challenge this, because a lot of systems are tested without including penetrating steel members like this. Yeah, next one. The next round of physical actuator tests that we tested were actually related to the other end of the spectrum. We wanted to see what happened when we tested very heavy actuators. So the main goal of the test was actually to see how much better performance do you actually get when you test very heavy body actuators. So instead of testing on a 10, 20, 30 kilo dummy object, we tested for massive 200, 300 kilo actuator equipment to see what would be the benefit in terms of fire performance. We have a test program here for 8 test pieces. So far, we have undertaken 6 of them. There are 2 more coming later this year. And this is all about getting extra data. When we test for heavy body actuators, and we can prove the improved performance for heavier weights, we are able to calculate down the thickness of the system, which in the end contributes to lower thickness, lower cost, lower complexity for design, and in the end provides the clients with more value for money in terms of fire performance and fireproofing. So this is still ongoing. We have 2 more tests coming here, but the results so far have been quite encouraging.
Yes, and just to extend a little bit, Adrian, previous slide, it's a good opportunity to introduce to the audience that we are working on the new materials right now. We are testing right now the new material to improve the fire performance, to lower the thickness, to lower the cost, and to reduce also the fabrication time, and to lowering the shipping cost in the end. So the material, it's pretty much the same. It's still epoxy into mesh and coating, but it's a new generation epoxy intumescent coating, and it can provide the better fire performance. It's approximately 80% longer fire duration. And the thickness benefits, for example, as a case for the actuators with a low failure temperature. Previously, we were operating depending on the temperature rise, but it was from 14 up to 33 millimeters in the worst case scenario. But right now, for the same cases, we can improve it with a thickness from 8 up to 20 millimeters. So this is significant, the thickness reduction. With a CSP, PFP, we have the same setup. And one of the additional benefits is also to improve the service temperature. So with the standard materials, we can go up to 120 Celsius degree. Above this, we have to utilize extra one layer of the insulation liner inside of the box to prevent the epoxy from expansion. With the new materials, we can go up to 200 Celsius degree. One extra sections for the innovations, the small innovations, actually the accessories. We are testing the ventilation grill, which is made from epoxy intumescent coating. And this is to enhance the drying and ventilation abilities. So for example, if you have a pneumatic actuators from time or during the air stroke, it can release up to 400, 500 linear meters of the heated air. And this ventilation grill will help you with this. Then the second solutions could be the epoxy intumescent coating that could be utilized, for example, for the valve positioner or limit switch box. According to the API, that component should be outside of the fireproofing to see the status of the valve. But in fact, this is deviation from type approval because it's outside of the fireproofing. In case of the fire, it will melt after approximately half or 1 second. Especially, it's made from the plastic. So maybe it's a good thing to include this component inside of the box and incorporate the intumescent glass on top of that. So the project will have a constant access and visibility to see the status of the valve. And the same principle can be utilized for the electronic display in the electric actuators. The hinge door, that was the request from our customers that instead of using inspection hatch, maybe we could develop the inspection door with the hinges, and we are testing this setup right now. So it's more comfortable for the operator. When it comes to the sensors, we are as optional device, we can provide with the project. The application, the sensor is connected to 5G cellular network. So for the new build, that's not the issue. Same with the existing facilities. So we all the time do some pre-checks if the sensor is working on a particular facility. And this sensor it can gather the data for the client, which have access to the different dashboards through the web page access for registered users. And this sensor, it monitors the temperature inside of the fireproofing. Then it can detect the water, of the water, and can measure the water wetting, and also can monitor the humidity, which is important for the contour pattern. Service temperature is from minus 40 up to plus 80 Celsius degree, and it's X certified. So here you have an example of the different dashboards, and with a compact dashboard, so you can switch over to any dashboard you like. And here you have an example with a sensors inside of our box, and we also checked if it's any interference between the box and the sensor. It works perfectly. As one of this as a last slide, we would like to also share our experience with a different fireproofing solutions. We are sure that you are familiar with other removable PFP solutions on the market, on the valve and actuators. And we are in the industry since 2002. And we, for some of this photo we've seen by themselves, and for some particular project, we replace those damaged solutions by the Benarx Epoxy Box. So the first solution is fireproofing jackets or blankets or cover or mattress. It's It's the same product but different product nickname. And it's made from a technical fabrics in field with a fire starting insulation, like a mineral wool, fiberglass, ceramic wool. And we noticed there's a lot of industrial evidences that the jacket itself, it's easily tearing apart. So integrity, it's not intact. It can absorb the water due to the fiber insulation. So it can they can be 5 times more heavy, and they can give you the extra weight impact for the actuator of the valve, cause the overheating. And another issue could be the fixing methods due to the heaviness of the jackets. They can easily break up. Can stick oil contamination, which can weaken the fire performance, of course. And after the time, we see also that the jackets, they have a tendency to lose the shape, so they cannot protect well the certain components as designed area. And due to the water absorption, they can propagate the corrosion under insulation. Another solutions could be the directly bonded fireproofing. The valve and actuator must be disassembled and sent to the workshop for the coating applications, and then sent back to the customer, and then the valve and actuator must be reassembled again. So this is a little bit problematic when it comes to the project schedule, and it's quite costly due to that some of the valve and actuator are very heavy, so transportation costs are significant. But we also see the problems with the coating itself, because it's a lot of issue with the coating this integrity, and it's quite thickness. So when you press too much the coating, for example, you're trying to connect the cables, then it's easily to break up the coating itself. And the service temperature for this particular case is approximately 80 Celsius degree. So it cannot take up higher temperature. Another solutions could be the molded fireproofing shells. The vendors who making that, they're using the stainless steel, not stainless steel. They use the molding, and then they use the injection molding for the epoxy fluorescent coating. We notice the issue with these solutions that due to sometimes the low pressure during the injection molding, it can be brittle. So if you take the shell part and try to drop up from a half-meter height, it will break up. Another potential challenge is that due to the small air gap between the object, they have a problem to accommodate the cabling and the tubing inside. The service temperature is up to 120 Celsius degree only, and we notice also it's not always UL 1709 certified. Another potential solution is stainless steel or general metallic enclosure fulfilled with a static fire insulation, like a mineral wool, ceramic wool, and fiberglass, etc. And this is the same case now with the jackets. They absorb the water. Then it's very difficult to remove it. If you manage to remove it, it's nearly impossible to reinstall it. And it's very heavy. And this, due to the metallic enclosure, it's easily to scratch it. If you step in on the solution or step out, if you put the ladder or heavy tools, it will be damaged. It will be dented, bended, and twisting. And during the installation, it's also a lot of sharp edges and corners. It's easily to hurt yourself. And we see also several proofs from the industry. They've been impacted by corrosion heavily, as you can see on one of the pictures. All right. So I think this is related to the presentation. So thank you very much for your time. Now we would like to start the Q&A sessions. I know that we use a little bit more time than intended, but feel free to use the Q&A button and try to ask the question to us, and we will try to advise accordingly. Adrian?
Yeah, I'm typing as fast as I can.
Okay, so you.
I've done quite a lot of them already, actually.
Okay, so you respond on.
Yeah, I'm on it.
Okay. Okay. No, my intention was to read the questions, and both me and you could reply on those questions. But since you already reply,
yeah, if you go to the answered section, Damien, you will see 25 of them, which you can start reading from if you want. There are 18 open still, so I have some work to do here.
okay, so I will start reading for the answer, so everybody can watch this on the recorded webinar placed on the YouTube afterwards. How would air gap impact performance of the PFP? So Adrian response: the primary impact is the air gap needs to be large enough to accommodate the intumescent epoxy expansion. As a very rough rule of thumb, air gap should be at least the same thickness as the epoxy, preferably 1 to 2 times at least. One of the user respondent, a larger air gap between the equipment to increase the performance in terms of the back face temperature of the PFP. I think then you can reply on this extra comment, unless it's just confirmation about your previous reply. Another
I have
question.
to come back to it. I can't do every single dialogue. I need to go through the ones that's been asked first, and I will come back to the additional comments afterwards. Okay. Otherwise, I won't keep track of it. So I need to do it in chronological order.
Okay, go one by one. Another question: when removing the PFP for maintenance purpose, does Benarx specially needs to be around to do the removal later installing back? Our reply: not necessarily. We also offer remote training and the remote supervision through the teams. Okay. Another question, the third question, regarding ISO 22899 compared to UL 1709. The latter has a 5 limit to reach 1093 Celsius degree. Is there a timing also for ISO? Thanks. Adrian response: no, ISO 22899, it's only regulated based on the gas flow. The requirements is 0.3 kg per second. The temperature will fluctuate typically between from 1100 and up to 1300 Celsius degree. Another question: for installing of the 100 fireproof, you said require 15 minutes. How many people is to perform? Is it 2 people as a picture on the slide? The response: yes, typically 2 persons. We designed the box part to be made 20 kg for easy handling. In the meantime, I launched a survey, so I would like to get the feedback from you guys. So I would appreciate if you could respond on those questions. Thanks in advance. Okay, I will get back to the Q&A session. Another questions: which epoxy coating product is typically applied on the Benarx box? Is this prone to cracking due to the long-term exposure to the weathering offshore? Our response: we have historically used mostly Interfine 6 to 9, but we also use Intertain 990, but have a good track records, 15 plus years in terms of the no cracking, delamination, UV resistance, etc. What's the PFP epoxy product used? It's Chartek, so I can reply on that. Another question: if the PFP box applied to the valve and there is a gas leakage from the valve and built up inside of the box, will there be some kind of the pressure release from the box? Will there also be some kind of the identification that the box is now under pressure due to the gas release from the valve? In order to address the concern, we normally propose sniffer tube, which allows operator personnel to check against leaks or gas leaks. Another questions: Is there a specific certification needed to install the box? Our response, yes, there are several options here. Benarx can supply supervisor, which will guide local workers. Client personnel can attend simple free for training course remotely through Teams. In this case, we issue a training certificate. Next questions. Is there a specific certification for tubing and cable link penetrations? Response, in some cases, yes. Depends on the factors, but particularly it depends on the whether the tubing cable link itself is rating in the sense that it must be fireproof. If the cable tubing doesn't require fireproofing itself, it's simpler. The next questions. Did you already perform real fire testing with operated valves and actuators? Or do you base your box design and intumescent thickness definition on the previous testing done on the structural tubular elements? Our response, we have done testing on physical actuators, not only steel dummy members. This will be shown in the later slides. It was shown, yes. Another question, what's typical design blast loads for the PFP? Our response, common blast loads range from a 0.2 barge up to 1 barge. In case of the green water slam wave loads, it can be much higher, even 1, 2, 3, or 4 barge. Another question. Does the PFP need additional support to ensure it remains in place or just purely attached to the equipment? Response, sometimes yes, if the box is very large, heavy. Usually it's not required. Another slide. Your slide states that your products are UL 1709 certified. However, UL 1709 doesn't currently include testing of PFP for actuators. Therefore, how can you claim the UL 1709 certification? Our response, we have a UL 1709 testing included in our Lloyd's type approval. Another question, how does the Benarx box perform to meet the acoustic requirements? Curious, as the coating is fairly thin, I'm guessing. Is there any other elements added during the construction of the box for acoustic boxes? If yes, please clarify what are the elements. A response, for class A and B, according to the ISO 15665, the box itself passed the test requirements. For class C, additional aerogel insulation is required. Another question, how does the box PFP compare to the typical PFP box made of the thermal insulation material, aerogel, in terms of the weight and cost per unit, considering same size, geometry, and other parameters? Response, very roughly speaking, it's often similar. Next questions. Any special tools required for removal and reinstallation of the Benarx PFP box? For most design, and the response, the most design regular insulator tools will be sufficient. We can send you the extensive list of the tools after the webinar. Next question, what's the weight of the material per square meter? Response, depends on the thickness of the epoxy. A rough rule of the thumb is that weight per square meter is thickness plus 5 kg. So as example, for 8mm box, it's 8 plus 5 means 13 kg per square meter. Another questions, what's the solution for the PFP box used for the cold insulation required valves? As we know, cold insulation box normally it's not removable. Response, correct. Cold conservation insulation needs to be installed first with intact vapor barrier. The removable box, therefore, doesn't include the cold insulation itself. This is not to be confused with a cryogenic spill release, which relates to LNG spills coming from the outside. Next questions. For the sealant that is used for the PFP box has been installed to avoid water ingress. Is the fire rated 2 according to the equipment fire rating? Response, sealant is not related to the fire performance, only water sealing. We use NitoSeal SCN, which is a silicone-based sealant. The product has been tested in our system for weathering, aging according to the ISO 20340. Another question. Upon exposure to the fire, the epoxy material will expand. Since it's confined inside the steel box, where does the expand material go? Response from Adrian. It used the air gap between the box and the equipment. This gap accommodates the expansion. Okay, another question. How about the requirements comes with a combination heat conservation plus acoustic plus fire? A response. This is one of the cases where our product can produce very good benefits. Since we have tested our epoxy system in combination with acoustic insulation, in the acoustic test, we are able to reduce the amount of the acoustic insulation needed due to the inherent acoustic performance of the box. This reduces the material cost, thickness, and the complexity of the product. Another question, any additional support required, or is it just resting on the pipe and flame? Response, in many cases, it's resting on the pipe or actuators, but very large heavy boxes might require supporting frames. Since the valve and actuator boxes will follow the equipment geometry so closely, it's typically not able to move anywhere. So for most cases, no frame is required. Good answer. Okay, next question, what's epoxy PFP is being used? Yeah, the response, typically we use Shartex 7 from AkzoNobel, but we have some produced based on the Pitcher XP from PPG, which we supply for piping in some projects. We are also testing newer product technologies here, particularly in recent tests undertaken. Yeah, that's correct. For boxes on the valve and actuators, we use only the Shartex 7. For the piping containing the Pitcher XP, we have a separate system called Benarx Cellular Glass XP for the critical piping that needs the fire insulation. But this is the separate system, and it's not included on this webinar. Question, the next question, there are different colors shown. Is it based on the client requirement or is it different product itself? Response, standard color is white, but we can supply the boxes in any colors the client prefers. Another questions, any maintenance required? Response, very little, typically just visual inspection and some coating touch-up in the case of the scratches from operation on site. The boxes hold up against the tide of the time remarkably well, and we have boxes which have been in field for 15-20 years, and they still look very good. They collect some dirt like everything else over time, but simple pressure washing will remove it. Very good answer. Another question, in case where there is a very limited space, high possibility of clashes with adjacent surrounding items, components, can Benarx boxes to be installed very close to the component to be protected? Or does it typically require some form of standoff distance from the surface of the components to be protected? Adrian response, we can install boxes with a very narrow spaces. As low as a 50mm space are typically no problem, but depends a little on the epoxy tip. Next question, what will be minimum and maximum operating temperature of the product, considering cryogenic services also? Adrian response, for maximum operating temperature, we can use our system on equipment with the operating temperature as high as a plus 120 Celsius. This is due to the air gap, which separates the box from the underlying process temperature. Above that, the temperature we need to add insulation. For cold insulation, like a cryogenic service temperature, additional cold insulation is always required on the equipment before the fireproofing is installed. That's correct response. Another questions, in case where there is a ESDV on the riser, porch, balcony, and might be subject to green water, is it any form of the mechanical protection considered and installed on the outer surface of the PFP box? If yes, please clarify what form of the mechanical protection will be. Other response, in these cases, we often need to install a metallic frame inside of the box in order to strengthen them sufficiently to resist the green water slimy loads. This is particularly relevant for large objects and when green water slimy loads exceed 2 bar. Next question, is the product applicable for small size valves? Example, 2 to 3 inches size valves. Response, yes, but we need to check that the weight of the object is within our test and type approval. There is a limit here on the object weight versus passivity. Yeah, it's the last question is about the agent from typing, but I didn't fix it. Adrian, are you working for the new questions?
Yes, I'm still typing.
Okay, you're still typing. Okay, sorry. Okay.
So I need to keep muted to avoid the troubles.
Okay. And a new question arrived. What sort of the preventive maintenance is required to ensure the PFP integrity? Adam response, visual check that there are no visible damages. Damages to the top coat, it's okay. There is no particular mandatory maintenance operation to be done. And the last one, it's in some cases, coating can be scratches where regular touch-up paint repair is sufficient. All right, very good. Okay, new question arrived. Due to space constraint and site modification, if there any clash with nearly objects, then modification permitted by the installer, or does it require Benarx vendor to modify? After modification, does it require recertification? Adrian response, in case where clashes happens, box can be cutted, latched, partitioned, and modified on site. For simple modification like a cutout or moving of the logs, little guidance from Benarx is needed. Our installation manuals will give you a good enough guidance. For more complex modifications like a partitioning or latching, we propose to have a brief 3-4 hours Teams meeting to guide the local workers how to carry out the work. We can of course offer the service, but For a minor case, it's often more cost-effective to provide supervision remotely. We are quite flexible here. All right.
Yeah, I see the question just keeps coming, Damien. So I'm not sure how long we should keep waiting, or if we just call it.
Let's what we can do, Adrian, we can stay on the line 5 extra minutes, and
Okay.
after this we just notify the audience that we will come back with the rest of the questions after the webinars with our replies. So anyhow, I will collect all the questions.
Yeah.
And I will send to everybody.
Okay.
So keep going for the 5 extra minutes.
No worries.
All right, the new question arrived. Do Benarx provide after-sales warranty service? If yes, how long the warranty period will be? Yes, we do issue warranties. The commercial warranty period varies from project to project. In some cases up to the project contract terms and conditions format. But typical warranty can be several years, for example, 2 or 3 years. Warranty period is not to be confused with a lifetime. The lifetime of the product, it's a plus 20 years. And we have a 15-20 years track record performance for the product in the field. Okay, your question. If we consider installing an acoustic box on an uninsulated piping, but only require a localized acoustic box, then how does the termination between the acoustic box and the piping take place? And the end caps, how do you prevent the water ingress and this termination? And the reply, localized acoustic insulation typically only work for high frequency noise. Low frequency bass vibration typically distribute through the pipe and out. So it's it's generally risky in terms of the acoustic performance to insulate only localized parts of the equipment. In this case, we would propose to use the standard sealant to make an airtight seal against the pipe. Okay. New question arrived. If the PF box is very heavy, does it require any form of the support trunnion to be installed to support the weight of the box? The response for a very large heavy box is yes, particularly for large vertical valves and actuators. New question. What will be the maximum operating temperature of the equipment that can be protected? Plus 120 Celsius degree. I think this is just for the pure epoxy. Above this, we have to utilize the extra layer of the aerogel liner or go with a new material with a higher service temperature.
Yeah, I think we can round off.
Yeah, okay. For the remaining questions, gents, we will get back to you after the webinar. So we will send you the whole list of the questions with replies from us. And as a short closure, I would like to thank you very much for your attendance and for your time and for all these questions. We are quite happy that we received over 40 questions already, plus most probably plus 10 extra. So we will send you also the link to the YouTube with a recorded webinar afterwards, and we will send you also the certificate of the completion for the participants who've been participating in this webinar. Stay with us for the next webinars and have a good day. Bye bye.
Bye bye.
Okay, it was cool. Adrian, are you still with us?